Good morning, Tulsi, and welcome everybody.
Good morning, everyone. Thank you, Andrew, for letting me in here.
Is there
Um,
anyone else we should welcome before as we get going?
no, I think just the two of us can handle it for
Okay,
now.
great, great,
Great. Well, thank you all for joining. I can see that people are starting to introduce themselves in the chat. Please continue to do that. Give me 1 second here, and I'm gonna get us started.
great. Tulsi, I did have a welcome where people are poll, as assuming some people are going to join a few minutes late. Is
Mhm.
it all right if I'll lead with that?
Yeah, of course. Let's do it.
Yeah, so everybody, we're going to be using a polling software called Poll Everywhere, and we're curious where you are. So if you would, please write into chat. I see people are doing that. Someone from Grenada saying that they're here. So your name and where you are. And if you would, please go to this link at the top. You can see pollev.com, climate intern 935. And we're going to be using the polling a good bit. So please register there. You don't even need to register, just go open another browser window and join us there. Uh, and put a dot on this map. Where are you? We have someone from Italy, Heather Massey from Denver, Colorado. I see someone way out in Southeast Asia and some in Europe, uh, Canada. Great. So we really do, Tulsi, have the international representation we dreamed of. Yeah. Someone, Martin from Buenos Aires, Argentina. That's right, Martin, you are both a member of Planetary Health Alliance and an ambassador, a user of En-ROSE. Fantastic. Roa from Egypt, Hannah from Washington, D.C. If you're just joining, please go to the Poll Everywhere link at the top in another browser window or use the QR code in the top right and let us know where you're from. Kishi from China, Yuru from Japan, Ezekiel from Liberia. Come put a dot, a pin on the map and let us know where you're coming from to our webinar. Of course, this is Planetary Health Alliance and Climate Interactive together running a workshop with En-ROADS, our simulator that's going to help link actions and policy to planetary health considerations such as biodiversity, human health, social considerations. Other places on the map you're seeing, Tulsi, as people arrive?
Yeah, I'm waiting to see if we have anyone from Oceania, from Australia, or maybe Fiji, New Zealand. Oh, there we go. We have Ayasa from Japan. Perfect. I think we've got the continent covered. Now, if we find somebody from Antarctica, that'll be fantastic.
Has not happened yet. Has not happened yet, but there's a big blue area there at the bottom for them to aim for.
All right.
Well,
Shall we do it? Shall we get
yeah.
started? All right. Well, I'm gonna switch over to sharing my screen here, and I just gonna ask everyone make sure that they can see the correct screen. It should say PHA and Climate Interactive. Seeing some nods. Okay, great. So let's get started. Hello, everyone, and welcome to our webinar today with Climate Interactive. My name is Tulsi Modi, and I am a senior project coordinator with Planetary Health Alliance. I've been with PHA for a few years now. I'm sure a lot of people on this call know me, and I'm hoping that I know a lot of people on this call as well. And I've been working on a few different projects, including FAM 2025, which just took place in October, and of course, the highly anticipated FAM 2027. But today we are going to discuss what Planetary Health and Planetary Health Alliance is, and then we'll hand it over to our friend here at Climate Interactive. And then, of course, we'll leave some time at the end for questions. But this will be an interactive and engaging session, and there's a lot to get through. So we're going to get started. So first, a little bit about planetary health. First articulated in the 2015 report of the Rockefeller Foundation Lancet Commission, planetary health focuses on the ways that human cause disruptions to the Earth system affect human health. And given the complex interactions between human activity, environmental changes, and the many dimensions of human health, we will need all of society, including earth scientists, health professionals, economists, journalists, business people, policymakers, philanthropists, everybody in this room to drive solutions. And planetary health is transdisciplinary in nature. Our work is dependent on convening and bringing different sectors. Planetary health is grounded in systems thinking, meaning we know that solutions that focus on policy systems and context change have the greatest influence on protecting health. And then planetary health realizes the urgency of acting now. And has a explicit commitment to addressing the fact that those who are harmed most by the Earth's natural system disruptions are often the ones who were least likely to cause them. So to depict planetary health as an image for my visual learners out there, this slide represents an array of ecological determinants of health, which include climate change, but also includes pollution of water, air, and soil, biodiversity loss, and unsustainable use of scarce resources. It also encompasses a wide array of interconnected health impacts from infectious diseases to non-communicable diseases, and it recognizes the profound effects on food systems and the resulting nutritional diseases. It notes that the health impacts may especially affect maternal and child health, and addresses the mental health consequences of nature loss and disruptions that arise from disasters and dislocation, conflict, and other trauma from the Earth crisis. So PHA, Planetary Health Alliance, is a diverse community of over 4,500 individual members, over 500 organization members, and from across over 80 countries who are all committed to understanding and addressing the health impacts of global environmental change through community building, through research, education, mainstreaming, and action. And the PG's mission is really to promote, to mobilize, and to lead an inclusive transdisciplinary field of planetary health in its diverse science, stories, solutions, and communities to achieve the great transition. It's a comprehensive shift on how human beings interact with each other and with nature. So if you're interested in learning more, there are a few ways to get engaged. One is to sign up for a monthly newsletter. Maybe someone from the PHA team can drop a link in the chat in a moment here. You can follow us on our social media accounts. If you are a youth, we have a few programs specifically towards the next generation. Those applications will open in the fall. And then you can always join as an individual or as an organization at any time. And I mentioned this a little bit earlier, but we do co-host a annual meeting every year and a half or so. So the next one will be in June 2027 in Tokyo, Japan. And we encourage all who can to attend virtually or in person. And of course, as we have noted at the beginning of this call, there's a lot of representation from across the globe here, and we do have regional hubs to focus a little bit more regionally. So you can jump onto our website and connect with your regional hub lead. And with that, I would like to give Drew here a proper introduction. So Drew is the executive director and co-founder of Climate Interactive and a research affiliate at MIT Sloan. He is an expert on international climate and energy policy, a system dynamics modeler, a speaker, and a creator of policy simulations. He led the teams at Climate Interactive and MIT Sloan that developed En-ROADS and C-ROADS. We'll talk a little bit more about En-ROADS later today. And then two climate simulators used widely to engage global decision makers. His climate policy work has appeared in media outlets such as the New York Times, the Washington Post. And Jones has trained in modeling through degrees from MIT and Dartmouth College. He teaches systems thinking and climate policy at MIT Sloan, at Stanford, and at UNC Chapel Hill. And then he co-accepted the ASIS Applied System Thinking Prize and the System Dynamics Society Applications Award, as well as the Dartmouth College Ray W. Smith Award for the most significant contribution to the status of the college. He lives in the mountains of beautiful Asheville, North Carolina, and he's here with us today. So I'm going to
All
stop
right.
sharing my screen to let you take over.
Okay. Thank you. Thank you, Tulsi. Great to see everybody. Thrilled to be here. Our work is so aligned with your mission. So this is the dream kind of setup when we find someone who is so effective, a group that's so effective engaging people around the world, engaging policymakers and affecting policy and strategy and thinking, and we're able to empower you all and your communities with our tools. That's what we're going to do today. The core of this, and I'm going to not want to cut straight to it. The core of this will be in sharing insights from our simulators, an experience from our simulator, but also offer you the potential to engage other people with it and the workshop and game that we've built around it. If you haven't seen it, this is it. The reason it's so effective is that it runs really fast. It is a global model of climate and climate impacts that can show you what actions we can take to improve things. And you see some things about energy and climate here, but in a minute, you'll see the second big part of all of this, which is the many impacts of climate, the many threats to planetary health that are out there that you can very quickly see. If we take action around the world, how much better will it be in specific places? I saw someone, I'm going to try to, well, at this specific place, for example, if we had energy efficiency, how much better would temperature be out in the future? So that's the offer, a tool, an engagement process in a game or a workshop, and hopefully some insights along the way. But really, the first thing is just to ground ourselves. You're all here. You could be doing something else. You're showing up. Let's just ground ourselves in the threats to planetary health that matter to you. And I'm going to ask more broadly. I know many of you think in policy and think of other people, but let's just start here. So please open another browser window. And, or if you already did it, if you did the first poll with the map, but yeah, great, you get it. What is a threat? You've experienced air pollution. And if you would say, what is that and where? Biodiversity loss, different plants and animals that we care about. We're not seeing quite as much in some areas. Extreme heat, extreme heat. Hurricane Helene. I'm here in Asheville, North Carolina as well, and I'm experiencing that as well. Hot weather. Hurricane Helene was a hurricane that hit here in North Carolina a year and a half ago. Flooding. If you don't mind, add a location as well. Vector, malaria and dengue. Floods. We're seeing greater day flooding in many coastal areas. Extreme heat. Thank you. Okay, so more broadly, um, you just named some areas, and when you think of it, not just for yourself, but for the world, which of these threats are you most concerned about? Which ones, and frankly, we're going to go explore them. Now you get to vote kind of broadly. Extreme heat is getting the most votes so far. Uh, e- Air quality, biodiversity loss, wildfires, hurricane typhoons. If you're just joining, I put a QR code up here. You could actually just use your phone to vote as well. So take a picture of that QR code or open another browser, and there's a link at the top. Or you could join by text, send that message there to Climate Inter 935. Boy, extreme heat. Tulsi, people concerned about extreme heat, but then ecosystem change. There's planetary health, ecosystems, air quality, biodiversity, hurricanes, typhoons, cyclones. Okay, just getting a sense of what you're interested in. And I'm both going to give you this experience of how we use this tool, but I want you to have a second eye. The second eye is that as I'm doing this, this could be how you engage other people using a tool like this. And I saw Martin is in your community, and I'm in Argentina. He has been doing this, and maybe later we can get you to tell one of your stories of how you're using the simulator because you're seeing me do this, but I just want to note like the main use cases for this, the way that we tend to use this and what you can be doing is going to your top decision makers. Here's an MIT professor with John Kerry, who was the lead US negotiator with the tool. Jay Inslee, conservative, even conservative people like Senator John Curtis, who's the head of the Conservative Climate Caucus, very curious about climate impacts. Bill Nye, the science guy, there he is, Senator Mary Landrieu. That's one-on-one, but you also can take it to a group of people. This is members of US Congress talking with each other. What shall we do about climate and, frankly, planetary health? Talking with each other, grounded with this simulator. And where you all fit is that we've given this away to many leaders around the world. Here is Wakas in Pakistan, another group in Pakistan. Here is a teacher, so it's in Indonesia, Brazil, Eduardo Fracassi. India, here's Radha Sharma. Okay, you get the idea. This is a tool for you. But what I was curious about was what your interests were, and what I saw was extreme heat. So imagine that you're engaging people on this. The first place to go is then to this area, and you notice I just click on the title there. And one note, if you, like me, sometimes like to parallel process, I'm gonna share this link and then go to the chat, and you will be able to, there's the model itself. So we just made a link straight to it. And Beruz says, can you have the slides? Yes, yes. So Tulsi, we'll make sure you have the slides. You'll notice I don't use a whole lot of them, but the main thing will be this, the simulator itself. Click on the title, click on impacts, and here are all the impacts that you can look at. People said extreme heat. At the biggest, highest level, deaths per 100,000 people. Click on the three dots. Here's what we're very concerned about. Today, and you can mouse over, about 8 per 100,000 deaths are from extreme heat. But what we see is a doubling over this next 40 years, and then not quite another doubling, but you can see that exponential growth that we are concerned about. Now, when you see a number like that, when you're a scientist, you say, wait, where did this come from? So what you can do is look underneath and what is the paper this is based on? What is the science? And it can be helpful to say, oh, there is a study. Here it is. Vicedo Cabrera et al. Here is their study. Go read what was beneath it and get some more detail of what's underneath that number. With heat, we really thought there's a good bit of variation around the world. And so we made sure you could see that. It varies a lot by region, some because of the preparedness of the area, but some also because of the ecological differences. Southeast Asia is particularly prone to deaths from extreme heat, and Southern Europe, partly about how prepared, but partly due to ecological differences. When we see that, you see regions, it may make you curious about, well, let's go look at a specific place. So this is where, after seeing, okay, it's the numbers are high, but where? And that number about Southern Europe in particular was curious to me. And so you could go and look anywhere in this map. So you can see this idea of connecting prevention efforts to also adapting and what we need to do in different places around the world. In this case, we can see here in Southern Europe, and the use that we find when if you're curious about heat is to use this little button up here, go back to 2000. Much of the preparedness that we experience today when it comes to heat, how we have our buildings, what kind of social structure we have for cooling, uh, is built around decisions made decades ago. So this is a world decades ago when, I don't know, in these areas of France, this green area here or Dijon, that area, was 1 to 7 days above 32C or 90F in that area. 1 to 7. But then we can explore the changes through to today, through the 2040s and 2050s, to the point where that same area is now blue. It's shifting from 1 to 7 to 8 to 30. So this is just what's expected under a general no major changes to global climate policy future. And it's just helpful for people to see the, if you look at like this area around Vienna, the blue, the creeping of the blue into the green, for example, in Southern Europe. So you could go explore that as a way to people visualize what's coming and what we should get our human society ready for, but also our ecosystems, because this involves changes to the ecosystems that so many forms of life on Earth depend upon. Another way to look at it, if you like big models, is uh, you've probably seen these are the general circulation models. Usually they take months to run and they're the foundation of climate science. Here you can do a similar exercise. I'll go into France. You could go and look at extreme heat in that area and see a similar change from where it was in 2000 through the years as the temperature increase has come up here and where it's expected to go in the future. So you can explore those changes in any other area. So we try to be this platform for exploring impacts in different parts of the world. So it's a little bit about your concern about extreme heat. Now I mentioned the biodiversity changes, and you voted for that. So this is on human health, but it really matters down here for uh, because of that heat, we have ecosystem shifts. This is foundational to biodiversity. So you can help see how many million hectares, and I find this description really necessary. Global land shift at risk from ecosystems due to temperature increase, such as boreal evergreen becoming temperate coniferous, or Arctic tundra turning to temperate grassland. How much is shifting those areas in hectares? We can see that growth. That's a little abstract, right? Like you'd have to know a lot about ecosystems to understand what that means for the world. But what it really means for the world would be this, which is a very helpful diagram for biodiversity. Species losing more than half of their climatic range. Plants, 45% losing half of their range, therefore trying to migrate, frankly, to the usual niche or ecosystem they're used to, but unable to. They're losing some of their range. Mammals, note, we're mammals, down here, 24%, with the little gray line being where we are today. Now, this is a first, like the early wake up call. If you engage people, why does this matter? What should we be caring about? Here's some data on that. Next, you're going to say, what can we do in the future? And I will pull up one other that you voted for uh, because we'll look at it later. Uh, Air pollution. PM 2.5 emissions are part of 1 in 10 deaths on planet Earth today. This is so present around the world. If you've been to New Delhi, if you've been to Beijing, you've seen the challenge of these small particles, particularly emitted by coal burning power plants. It's been growing and growing. It should fall. It's interesting. It falls with some decarbonization and then rises in the long term as energy demand requires us. If we don't do anything, we would actually have more coal in the long term unless we do something about it. So there's your prompt. Can we do something about it? Can we make a better future? And that is the question to you all that then you want to ask. If you're just sitting with somebody, perhaps you would just say, hey, what should we do about this? But if you have a big group like you all, give them a list. Here is the list. So if you would go back to your poll again, if you want to just take a picture of it and vote, there's the QR code. Electrify transport. Let's get some more charging stations and electric vehicles, trains, etc. Buildings and industry, heat pumps. Hey, don't forget about methane and other gases, renewable energy, subsidies from fossil fuels, set a carbon price, make coal, oil, and gas more expensive because of its carbon intensity. Improve food systems, perhaps change diets, how we grow our food, what we do with the waste from the animal industry, energy efficiency and transport. Right now, food is getting a lot of votes. Interesting. All right. I didn't see that one coming, but maybe we'll go to food first. Electrify buildings and industry, food. Let's grow some trees, reduce deforestation. Reducing deforestation, of course, will have other impacts on the ecosystems in those forests. Think of Indonesia and Brazil and the rainforest. One note, now I'm putting my professor hat on. As you're doing this, you're not just getting things to test, you're encouraging people to start imagining a world they'd like. We just showed a world that we don't want to see. Now we're sparking visioning. Can we envision what we'd really like to see? Food, fossil fuels, energy efficiency and transport. Food, fossil fuels. I'm writing these down. Food, fossil fuels, energy efficiency and transport. Okay, I'm excited by this food angle. So here, what I do is I reset everything, go back home to this view. Before I test things, I want to show you just a little of what we expect. What we expect if the world doesn't increase its action significantly. We have a carbon price. 25% of the world has a average $20 a ton carbon price in China, Northern Europe, part of the US. So it's about $5 a ton. There's a very low carbon price. And you'll notice each of these solutions has the very simple approach. You can just change the carbon price, or you can go underneath. And this sits in the MIT museum, so it's ready for an eighth grade kid just to walk up to it and make changes. If you want, as you all are probably more savvy, want to go underneath, click on the three dots. In this world, we have energy efficiency improving. Click here and you can see on the bottom right the energy intensity, the how much energy it takes to deliver goods and services is going down over time. Renewable energy is steadily going up. It starts slowing its growth because we need more storage. Electrification, the yellow line shows the percent of transportation that's electric. It's going up over time as transport in from fuels in brown is going down. But you really asked about agriculture, and agriculture has a lot to do with methane. Methane is another really important greenhouse gas. I'll show you where it fits in the picture of all greenhouse gases. If you click on greenhouse gas emissions, over here, here's the graph that shows all that. And I want to make sure you can get to this. I'm going to share another link here. If you go to chat, you'd get to see this version of it with methane and greenhouse gases by gas. So this shows all the pollution. If you want to prevent climate change, you've got to address the pollutants. The gray area is from burning coal, oil, gas right here. Land use, deforestation, bioenergy emissions. But that blue area in the middle, that is CH4, methane. We also have fluorinated gases in yellow, gold, and then purple is nitrous oxide. But we're targeting right now the blue area, but it also is going to help us with carbon dioxide. Okay, in agriculture, just want to show some of the interesting many impacts of addressing food systems. So at the very base of it, if you want to go to very deep, what if we just had less food from animals? And as I decrease this, I'll change it over on the right. You can explore, some people frame this as like the silver bullet, like it's going to solve the whole problem. But here we are. If we have less food from animals, see over on the right, over time, you can see the blue line departing from the black. We would have less. And then what that's cutting in the top is the yellow areas, methane emissions from agriculture and nitrous oxide. We don't need as much fertilizer to grow the crops to feed to the cows and chickens and everything that are food from animals. So you can see an effect there. And it's not as much meat. This is more dairy, is what, at least with animals. This is not going after hamburgers, more going after milkshakes, frankly. But here we are, food from animals. But also notice the change on food waste. There's so much food waste around the world. These are a couple things that can change it. That is just the scale of production. But we've also learned that so much can be done with best practices in agriculture itself. What happens to the manure management, etc. So from livestock, and you see that yellow area shrinking as well. And then in crops, if we irrigate better. So you notice all those things brought temperature down zero point 0.2 degrees. Big impact relative to 2. Now, it doesn't get us all the way to the global goal of 2, but it helps. There are also some other impacts. What happens to deforestation in that world without even out any protection of forests? This is just the demand on chopping forests down to make agricultural land to grow the crops to get to the animals or to be wasted in food systems. So we want you to be systems thinkers who are connecting the dots all the way through that chain. Deforestation goes down, therefore land use emissions of carbon dioxide goes down. Uh, Now that's over on the right. Now it doesn't go to zero, but it is a cut to it. So you can see some of those connections that are really important. All right, so we've got things to 3.1, but we haven't touched the energy system. You mentioned fossil fuels. What can be done with fossil fuels? You voted for many ways. I'd like you to think of it in two main ways. There's the clean energy revolution is like the carrot. It is kind of providing an alternative to fossil fuels through the market. Hey, use this other stuff instead. Or the stick is more direct, like actually phasing out fossil fuels. Now, I'm going to do both. The headline here, both are needed. So watch if we have more work and watch this green area. Right now, we're assuming growth in renewables. This is where we get our energy. See that brown area? Coal, red is oil, natural gas, and blue. These are all stacked on top of each other. See that green wedge? That is the expected growth in wind and solar. Look how much we expect. I think I see a lot as I drive around. I have it right above my head here. Uh, but the wedges, see where we are in 2025, 26, like we are right here, 45. But look where it's expected to go. We're expecting a lot more. What is the number there? 366. So we're expecting a lot more. What if we get even more? We boost it, and we would need more storage for it to grow even more. What else helps? Electrifying transport and industry, energy efficiency. Now, I just did a suite of things that you would call the clean energy revolution. You can even imagine nuclear, or we could put fusion or geothermal, new sources that are alternatives here, these sorts of things. Okay. 2.8. Now, notice it is a contributor, but it didn't get us all the way there. And that's why it's probably smart that what did you voted for you didn't vote just for the clean energy revolution. Back here, P was phase out fossil fuels. 11% of the votes were phasing out fossil fuels. And here, carbon pricing, E, carbon pricing. Many of you voted for that as well. So you're going to see the necessity of the stick, which is more direct. How do we discourage fossil fuels more directly? Now, we can cut subsidies. Right now, that looks like just kind of like taxing. So push back on them this way. We can set a carbon price, which is highly effective, but politically not quite as accessible. We can also go in here and just scroll down and reduce new coal infrastructure. That is phase out. Now, mind you, coal is already being phased out through various policies, but that would be an alternative. And there's some evidence that the world is just choosing to do that because mostly of the health effects. So when we start to push more directly on it, we start getting closer to that 2.3 to 2 degrees. Now, I changed some agricultural emissions. We would also need to address methane in waste and in landfills and wastewater. These are the sorts of things that could get us all the way down to 2 degrees. Now, some imagine the possibility of carbon removal. That is pulling carbon out of the atmosphere. Uh, we have ideas about it, and we have allowed the testing of them. Some of them have equity challenges. If we planted a lot of trees on land, who lives on that land, for example? What happens to food prices? But some of these policies might get us the kinds of things that if we could pull carbon out of the atmosphere, might get us below 2 degrees. What would be the impact of all this? What would be the impact? Well, I want to go straight to one of the last ones I showed you before. The most surprising for me from the modeling is how dramatic the improvement is to air pollution. And not just how much it cuts, but how soon. Many of the other impacts, because there's so much momentum in all the heat built up on planet Earth because of the trapping of heat from greenhouse gases, it takes a long time for that heat to dissipate and re-equilibrate and go into the ocean. So the impacts change very slowly when they're heat-based, temperature-based. But when it's just don't burn the coal, don't put the particles into the atmosphere, don't let those particles get into people's bodies to disrupt cardiovascular function, asthma, heart disease, those sorts of things. Deaths fall and emissions fall quite steeply. So this is some of the better news also for costs, for the financial costs of all of the health problems that we see here. What were others that we looked at? We could go back and look at deaths from extreme heat. We really bend this curve where it was growing exponentially. We've really balanced it out pretty flat over time. Over here with species losing more than half their range, huge drops, not 50% for invertebrates, but 18. Mammals, not 24, but 8. And this is interesting. The studies that were done about, there was a special report that scientists did on the effect of 1.5 degrees in the future versus 2, maybe, gosh, it's got to be 6, many years ago now, but they noticed the sensitivity even between 1.9 and 1.5. So this is not policy-wise very accessible right now. But imagine if we could get down like towards 1.5 and oh, cutting deforestation would help as well. Notice the amazing sensitivity as you get to like 1.6 or 1.5. This is why the world has said, please keep the dream. 1. What's the chant that they do? Keep 1.5 alive. When you get down towards 1.5, look at how much these numbers drop of the species losing their range. the world is much more resilient to 1.5 to 1.6 than even 2. So if you get back to 2, you'll notice these numbers going up a good bit. Okay. So those are several of the impacts that we had looked at before. But please write into chat if there was another one that I kind of skipped over. Those
There
are some of
is
the ones that you,
actually, oh, sorry to
yeah, go
interrupt. There
ahead.
is actually one that asks to show the impact of data centers growing now with the AI explosion. If you have anything
Oh,
on on AI or data centers.
so my modeling team will object, but we are two-thirds of the way through adding it. The Hewlett Foundation asked us the same question. And the short answer is that it is coming. The, however, um, just because some of our serious users like Martin are out there, and I want you coming back. So this is, you see it says development version at the top. This is what we use to develop new versions of the model. So here is data center electric energy consumption in terawatts per year. It is expected to grow a good bit. That's uh, the bad news. Just before you get too concerned about it, uh, some of the good news is that it could be growing a lot faster. And this is the energy intensity. This is how efficient it's going to be. And we really see an upcoming significant drop through learning. So the bad news is it's growing a good bit. The good news is they're getting more efficient. And the good news for us with you is that we are going to explore and and maybe just an approach to how we do our modeling, we try to make assumptions transparent, particularly in something as speculative as how big is this industry going to grow? Like it could grow a lot more or a lot less. And really, we think of ourselves as the ability to play out assumptions. So we're going to explore those futures, but also some possible better news regarding the progress ratio and energy efficiency. Like this could come down even more. So, uh, no definitive answer. We're working on it and stay tuned. Okay, Tulsi, others that you saw, or did you write
Yeah.
people write in chat other impacts?
Yeah.
Because we just created a better future for the world.
One person, Paul, asked if we can add geothermal to energy sources, thereby replacing fossil fuel powered consumption.
Yes. So I'm going to hang on to this scenario right here because we did imagine something like 1.9. And so, and I'm going to share this with you in case you want to, uh, if there was a part of this you were like, oh, like I don't like nuclear, I'm getting rid of nuclear or something. I'm gonna make sure you have it. So here's this link to this one. And you just asked about geothermal. Um, and so what I'm going to do is I'm going to open another version of the model on its own. So you're going to get to see. So experimenting with something like that, how we think of it is there are many uh, new zero carbon sources, fusion, thorium fission, perhaps geothermal could be one of these. And so we imagine, look, we're on the right, what if there is a breakthrough? And you can pick the year that it happens and how cheap it is, how long it takes to commercialize. And so here, if we imagine next week there's a breakthrough, but maybe it doesn't take 20 years. It took uranium nuclear 14 years to commercialize. Maybe it took only 10, and maybe it's cheaper than coal. So then it grows in the bottom right. So this is speculative. This would be very fast growth of this new supply around the world. It would compete with coal, gas. It would also compete, well, what would it do with renewables, wind and solar? it would compete with that as well. So coal, it would crowd out some coal. It would crowd out some gas. It would also crowd out the expected growth we saw before in wind and solar because it's a competitive field. It's a big world. Many other places, uh, well, it's going to compete. The key is it is no silver bullet, partly because of the delay. Here's the pollution. This is the biggest challenge with it. Oops. Um, Here's the pollution from greenhouse gas emissions. It really helps out here in the 2040s and 2050s. We all know the priority is to cut emissions in the near term. So I put the red dot. Paris Agreement says we need the pledges to go through that dot in 2030. This is really a help in the 2050s, 2040s. So it could help. Perhaps it's part of other things, but so delayed. And it also, as I showed you, competes with the growth that we expect in other sources of zero carbon energy. But let's pull back here. Here's what, no, that's the, let's pull back all the way to this 2-degree future. Let's just look for a second at what we made happen. Bending the curve on deaths from extreme heat, biodiversity, and what did we see? There was no one thing. We're not in a big debate about the answer. We're really exploring that it takes many seeds to plant a garden, to use a planetary, nature-based approach. It takes many seeds in electrification, energy efficiency, and renewables, cutting coal and carbon pricing, removal of carbon, methane, agriculture, deforestation. It takes many seeds at the scale of individual, family, neighborhood, state, business, country, international multilateral agreement in order to make this happen. Third, it's possible. It is still possible to bend this curve of emissions to avoid the worst case scenarios. And when we look at health indicators, it is so much better in so many different ways. And I didn't even get into the hurricane typhoon implications. I didn't get into vectors, malaria and dengue, additional exposure to warming. So many interesting insights, excuse me, so many different interesting effects. Crop yield improvements, and I saw you had nutrition. I love that because of the carbon dioxide concentration, we're changing the nutrients of our food and the grains and others that we grow. So much could be better in this kind of future. So, no one thing takes many seeds to plant the garden. It's still possible. And much of the leverage was in the priorities, which, of course, we've known for years and years, which is to not burn coal, oil, and gas, cut methane, protect forests are the kind of top 5 things you can do. Anything that helps that happen in the next 10 years are some of the top priorities. But I want to come back to the fact that this is possible. And you mentioned things that you've seen on the impacts. You're here. This matters. And I've been talking about a computer model and trying to build up your capacity as a systems thinker. There's been a lot of science thinking about cause and effect, but we're also human beings addressing this together. So I'm just going to be silent for 60 seconds. And I'd like you to join me, be quiet, and think, what would you love about being part of a world on track to making something like this happen? As part of this planetary health community, as part of the networks that you're in, what would you love about being part of a world that is on track to making something like this sort of future happen? And what I'm going to do is I'm going to set a timer here to make sure I really give us 60 seconds. Excuse me. So, silence, 60 seconds. What would you love? Here we go. What a long minute. It's remarkable how long it can take. All right, another poll. You knew I was going to go there. Or let's see. Just a few answers to that. Go to the poll. What would you love? What would you love? Why are we here before we get back to looking at this model and using it in the world? What would you love? I'd love to hear a few answers. I love that sensation of togetherness, of being able to look around the world and see other people aligned in this vision of a world that works for humans and for other forms of life on Earth that really protects the future. Cleaner air, abundant forests. Love to be part of a world that is truly progressing because it means that people are more aware, responsible, and united. I'll come back to more on that one. Uh, Knowing that everyone is working together for a better future would give you hope and motivation. You'd feel proud to contribute in small ways to positive change. It would be a sense of security and belonging, knowing future generations would benefit. More natural spaces to gather. You'd like to reach out to high school students and getting them to discuss solutions. Knowing that future generations will live in a healthier and more sustainable world. That's intergenerational equity. Well said. Boy, you wrote fast. Someone really tells you got someone out there. The sense of unity. Yeah, that's what I mentioned as well. That sense of unity. Happy people, happy animals. They get to be happy too, don't they? Restoration of hope that we can create together a future in which all can flourish. A world where health professionals and all consider the health of not only humans, but of animals and the shared environment. One health approaches. Health as a priority in decision making. A world that we collaborate to reach the same goal, reducing health inequalities. People and animals are safe where they are. The feeling we actually did something. We didn't just study climate change and pollution in class and move on. Great. Thank you. Thank you. All right. So, some of the offer, I told you that we uh, I wanted you to get those insights about what it takes, what's possible, uh, what changes in the future, what is avoidable and what is not. But the other offer is as you work to meet your goals as part of the Planetary Health Alliance, like Martin in Argentina, this can be a tool that you can use. This is a tool that many people in the world have used. I'm looking, I bet Martin's down here somewhere. Uh, but for example, people in different places, Brisa in Argentina, Hernan, here 14 of somebody doing something, where people are running workshops using these tools in different places around the world. So the invitation is there is a training that you can use in order to learn how to use our tool, much as I just did with you. Are there other follow-throughs, Tulsi, that you would offer to the group of how to proceed to meet some of the goals that people have?
Yeah, how to proceed to meet some of the goals. I think one just you can use this tool in a lot of different capacities. Drew, you and I were talking about the demographic of people that might join, and a lot of researchers, a lot of academics on the call, but I'm sure there's some advocates who can really leverage some of the information that they find here to drive their point across. I'm sure you can think of a
Yeah.
few more.
Well, I just want to mention, you did mention researchers and academics and scientists. Uh, you noticed I really shared and emphasized the engagement component of this tool. But many people are using it to uh, do their own research. So, like, it is a mathematical tool that you can go and like copy all the data from a scenario and write a paper about solutions to climate change. So you can get the data from any of the graphs that you just saw. And for those scientists who are like, well, wait, how did you do this? How did you build confidence in such a model? Every equation is here, shared in our technical reference guide, and all of our testing as well, where, for example, there's a whole suite of other simulations that are out there, integrated assessment models, and we do a lot to share how do we compare our scenario to theirs under a range of scenarios, and then all the statistics for those tests. So there's a lot that a scientist can do, and many people have used this to write papers, do their own research, because it is just a tool for you all to use out there in the world.
Drew, I know
Um,
we only have a couple minutes left, but I
yeah.
wonder if we can maybe answer one or two questions that came in through the chat. There were a couple of people that asked about if there will be any health implications or impacts that will be available to measure or to see with En-ROADS.
Any health impacts?
Mm-hmm.
Yeah. So I think we probably touched on several. And when you go up to this area of impacts, the main health impacts that we look at will be deaths from extreme heat, where we started before. Outdoor labor losses is a health impact. Of course, all the ways that river flooding affect the number of people. So these, malaria and dengue, air pollution, nutrition, these two that we looked at before. Um, Wildfire danger with all of its effect on health. Those are the main health ones that we have added. And frankly, Wellcome Trust, the foundation asked us to add many of those. Oh, and I see John Kirk is adding about using this as a in games. And yes, we do share the engine to those kinds of use cases, John. So yes, please get in touch with us because we can do that. And Martin is suggesting many of the other resources that are there. Do you see another question, Tulsi, in our last minute?
Yeah, there's a question about showing the impact of human behavior changes that reduce waste and such as
Yeah,
overconsumption.
yeah, yeah. When it comes to changes in behavior with like simplicity, lifestyles, and consumption, one of the places to look would be under here, under economic growth, because this is consumption of goods and services. So we can imagine different futures that do things in the near term or in the long term. What can be done if we were to need less consumption to meet our needs? So that's where it would show up.
Great. And then a couple of questions about the availability of slides or recording that we can share after the call.
Yeah, I believe that if you signed up for the webinar, you via Zoom will get a recording of the webinar. So know that that is coming. And the slides for the overall workshop are in on the website here of resources, I think. So here, uh, for En-ROADS, like all of the resources and all the slide decks are shared under here under En-ROADS. There it is, the resources hub. So if you go under En-ROADS here, there are slide decks, supplementary slide decks, etc. So all of them are under here to empower you to use this however you like.
Great. Well, thank you so much, Drew, for joining us this morning. And thank you to all those who attended this call. I know it's not always at the most convenient time, especially looking at where people are joining from across the globe, but we do appreciate it. And hopefully we'll do another one of these in the future.
Yeah.
Yeah.
Tulsi, thank you to you and the Planetary Health Alliance for your leadership and your hosting and bringing these great people together. Uh, what an honor to be part of your community. And oh, look at these nice things people are writing in chat. Aw, love
What a great
it.
way to
People
start
are
our
writing
day.
so many nice things. You're welcome, Andrew and Kasumi and Heather and Kwang Yo. Yeah, Rohini. Okay. Beruz says, go get them. That's my tagline in the training. So I see that you've done the training. Um, Fantastic.
All right. Well, thank you all.
Okay. Bye-bye, everybody.
Bye, all.